In the Dorothy project, several tools have been developed for supporting design, configuration and reconfiguration of flexible multi-site, multi-nation production factories for manufacturing mass-customized shoes. Amongst them, the Factory Layout Planner is a collaborative tool for three-dimensional design of the factory layout and simulation of its performances. In this demo, 4 actors will concurrently contribute to the definition of a layout using different clients of the FLP, thus exploiting its distributed architecture. The Factory Manager using a desktop client. The Simulation Manager using a second desktop client connected to the same FLP server. And the Production Managers using the multi-touch client that is meant to allow a user-friendly collaborative design on multi-touch devices. The Factory Manager uses the Multisite functionality in order to browse the existing production sites, and then decides the one who needs to be rearranged to host the production of the new shoe collection. The Simulation Manager does the same and joins the collaborative design session. Now they can both interact with the factory objects, and each applied change is propagated in real time to all the connected actors for immediate visual feedback. The Factory Manager decides that a new production requires the duplication of a part of the line, and so it starts introducing the needed equipments. From a catalog of predefined resources, it can easily add the new machines and operators by simply drag and dropping them in the main window. In doing so, he is supported by the Affinity Advisor, a case-based reasoner that, by analyzing already existing layouts, is able to suggest which resources are more likely to be used in relation to the selected one. Now, the Simulation Manager starts checking the introduced modifications. By interacting with the visual interface, he can create the connections between the added resources, thus ensuring the coherence and completeness of the logic of the modified production line. Once the task is completed, it makes the system check the consistency of the introduced changes in the simulation model. Since everything is fine, by selecting a production schedule, he can run a simulation in order to observe the efficiency of the new designed line in processing it. An animation shows the status of each resource during simulation time. Parameters like processed units, Q, saturation are displayed, and at the end of the simulation they are summarized in a table. Simulation data are automatically stored in order to be available for comparison with later ones. At this point, the production managers come into play, making their experience at shop floor available for enhancing the final layout design. A multi-touch device, along with its dedicated FLP client, allows them to interact with the layout in a simpler way by using perceptual gestures. By combining them, they can rotate, pan and zoom the viewpoint on the layout in order to obtain the most effective one for the operations they have to perform. The interaction with the layout replicates most of the functionalities that are available on the desktop client. In this case, one of the production managers, basing on his experience, decides to replace a roughing machine with a more efficient one. At the same time, the other production manager rearranges some machines for making more room for the operators. Once the modifications are applied, a new simulation is run in order to verify their effect on the production line performances. The new report can be compared with the previous one in order to highlight the existing differences.